This module is a continuation of the previous and discusses the energetics of African easterly waves. At the end of the previous module, we mentioned that a reversal in the typical meridional gradient of absolute vorticity, such that it decreases with latitude, is a necessary condition for barotropic instability. The meridional gradient of potential vorticity can be described by the Coriolis parameter f and the stream function, particularly the Laplacian of it. If we assume the meridional flow is negligible and that easterly flow dominates, then we can express the PV gradient in terms of the mean zonal wind. Barotropic instability of the easterly flow, which can amplify the easterly waves, can only occur if this gradient is negative. The figure shown here shows mean PV over West Africa on an isentrope approximately located at 650 millibars. The shaded region indicates where the meridional gradient of PV is negative, satisfying the condition for barotropic instability. It occurs where the easterly jet forms, downstream from the origin regions for easterly waves. Maximum diabatic heating, which is denoted by the contoured lines, tends to occur to the south of the region of the negative PV meridional gradient. A positive vertical gradient of latent heating with height is a source of PV, meaning that convection acts as a PV source to the south of the region of negative PV gradient at low levels, helping to determine the location of where the derivative reaches zero. The instability allows for the maintenance of easterly wave disturbances over West Africa and their growth. The mean latitudinal distribution of PV at 650 millibars is shown here, both for Africa in the solid line and Australia for the dashed line. A similar reversal in the sign of the PV gradient is seen over northern Australia but doesn't correspond with easterly waves. So we'll focus on just Africa in this module. When the barotropic instability is present, the zonal mean kinetic energy can be converted into eddy, or wave, kinetic energy. Plotted here is the barotropic conversion, denoted by the expression highlighted in red, which highlights the effective horizontal shear, or the extraction of energy from horizontal shear, to the wave motions. The x-axis is the difference in latitude from the reference point of 11 degrees north. This barotropic conversion term has a maximum value at about 700 millibars near the latitude of the easterly wave packet. The southwest to northeast orientation of the rotational flow in the wave, like we saw in the previous module, implies that easterly momentum is transported southward into the jet region through this eddy covariance term. Baroclinic conversion of zonal potential energy to eddy available potential energy is dominated by the term plotted here, which depends on the eddy covariance of the meridional wind, V prime, with the temperature, and then also the meridional gradient of the mean background temperature. This expression is positive at low levels near the Sahara, right here, because the northerly winds are often co-located with high temperatures, thus fluxing heat southward to the region of highest meridional temperature gradient. However, the conversion of eddy available potential energy to eddy kinetic energy indicates an energy sink generally near the location of the jet, and just a small source of eddy kinetic energy near where the eddy available potential energy is generated. Combined, the effects of barotropic conversion of energy, in other words, the transfer of energy from the mean flow to the eddies by the horizontal shear of the horizontal flow, seem to contribute most to the strength of the easterly jet, which is indicated by its co-location with the jet from a couple slides ago. However, more recent studies have suggested that the relative importance of barotropic and baroclinic instability in the jet may depend on where in the life cycle the jet is. The top panel, like one from the previous module, indicates the track density of easterly waves in the Atlantic and Pacific, while the middle panel highlights areas where easterly waves form, which are pretty much in the same locations or on the eastern edges of those locations in the Pacific. Formation of easterly waves is preferred in areas where growth of the disturbances is dynamically supported. One of those areas, West Africa, is denoted by the dark shading in the bottom panel, indicating a positive growth rate of easterly wave amplitude. The other location where easterly wave growth occurs is in the East Pacific near the Panama Bight. Examining easterly wave growth in the East Pacific more closely, we look at budgets of eddy available potential energy first, which I might just call eddy APE from now on. The term plotted on the left in all of these panels, which is the first term on the right-hand side of the equation of this APE budget, or eddy APE budget, describes the generation of eddy APE through spatial correlation between the temperature and the heating anomalies. This is a diabatic source of energy. The second term, plotted on the right, shows conversion of eddy APE to eddy kinetic energy. The final term describes baroclinic conversion of APE, but is an order of magnitude smaller than the two terms displayed. Also plotted are how the two terms vary with subseasonal variability of the zonal wind, associated with features like the Madden-Julian oscillation, which we'll discuss in a future module. This variability occurs on timescales of 20 days or more. Generation and destruction of eddy APE are more common when background zonal winds at low levels are less easterly than normal or more westerly than normal, such as in the middle panels. We see the big bullseye of red and blue corresponding to production of APE and then conversion to kinetic energy. Regardless of conditions, though, the two terms largely cancel each other out, as the eddy APE produced by convection is converted to kinetic energy very quickly. The largest sources of eddy kinetic energy, which is budgeted in this equation, in the East Pacific easterly waves are both the eddy APE to kinetic energy conversion just shown, which is this term, plotted as the second panel here, and the barotropic conversion of zonal mean kinetic energy to eddy kinetic energy is shown in the first panel. So these are the yellows and the oranges in this region indicating the production of kinetic energy. The first term is essentially the same as that shown a few slides ago from West Africa, and we find here that it's also a source for amplification of easterly waves over the East Pacific.